Hi, I'm John Keel with Upsony LLC, producer of EyesBot Driver, a robot controller for iOS devices. If you have an iPod and you have a soldering iron and you're interested in creating a robot which has a web interface, video streaming, and is controlled using your iPod, this is a video for you. The first part of the video will be a brief demo of EyesBot Driver in action, and the bulk of the video will be about how to create a robot.
There's the robot on the floor, and here's the interface for the robot controller. I'll go ahead and first turn on the lights, and you'll see the lights are on, and I'll turn the lights off, and I'll start to move the robot around. And here it is.
The bulk of this video will be about how to turn these components into a robot. There's a shopping list included in the blog that's referenced in the video description. The board is now populated, but nothing's been soldered in yet. The board basically consists of an H-bridge which will control the left side, an H-bridge which will control the right side. Up here there's phototransistors. The phototransistors haven't been added to the board yet, but these are the pull downs for the phototransistors. These are 10K pull downs, and these will connect to the Arduino Pro Mini. Will fit in the middle here. There'll be more headers stacked on here to give it some air room. That is to improve air circulation around the Arduino. But the phototransistors will basically be connecting to analog 0, 1, 2, 3, and 6. And then on the output side, this will be there'll be outputs from digital 3, 4 will actually run this. There'll be a connection from 4 to this transistor, which will run the headlights. Also digital 5, 6, and 9. So each of these, you'll note that there's two base resistors coming off of each of the digital outputs. That's because there isn't room for them to be connected separately. As long as the connection is on the digital pin side, that is the two resistors are soldered together on the digital pin side. So in this case, or with this configuration, a single pin will drive two resistors. So for example, this will be left reverse and this left forward. So when digital pin 9's on, it'll be left forward. There's also diodes, and this is to prevent back EMF from the motor. The motor will be connected here, and the other motor here. And there's also small caps. This is also to help to absorb some of the noise from the motor. The small transistors for running the lights. In each of these cases, or in each case, there's a positive connected to the collector, which is the center pin, and then it then connects to the motor connection, and the return is via the center pin, and then out the emitter on the tip 120. The base on the tip 120 is to the left. That is the leftmost pin with or the left pin with the lettering facing you. There's, in the blog, which is referenced in the video description, there's a diagram showing how this lines up on the proto board that I'm using. So no need to use this for that purpose. It's better to use the diagram in the blog as it's easier to follow. So I'm going to start soldering. I solder in 3 phases. First, the headers, the resistors, and the wires. Second, the transistors and the diodes, and then later I'll be adding these are current limiting resistors, and there's two of these white LEDs, which are the headlights, and then additionally there's the phototransistors. So first phase is the wires, resistors, and headers, and capacitors. At this point, the capacitors, the headers, and the resistors and the wires are all soldered in place. It's worth pointing out that there's two solder bridges, two sets of solder bridges that are required for the motor controllers on each side. That's because this pad that the motor connector is plugged into only has place for two leads to stick through and be soldered, whereas there's actually the capacitor and then these two from each of the sets of connections to each of the sides of the H bridge on each side. Other than that, the next step will be to solder in the tip 120s and the diodes. At this point, the transistors are soldered into place as well as the diodes. Additionally, I've added the headers. These headers that are stacked on the shorter headers will get the Arduino away from the board to allow more air circulation. So the next step is to add the phototransistors and the headlights, the white LEDs. So it helps to look at this in context before continuing, because at this point there's one can customize it depending upon the type of robot body. For the robot that'll be built today, this is the board that will be completed. The headlights will be pointing out on this side, the phototransistors on this side, and there'll be something to hold the iPod. The iPod will be pointed that way so that the video will be coming from this way, and then there'll be a caster added to the back here. The wheels will be on the side. So it helps to see this in context, to see what the next steps will result in. So this is the iPod shown with this sort of minimal robot that will be created today, created for this demonstration. So the headlights will be sticking out the front here, and these are the phototransistors which will be soldered in place. So what will happen is, as this as the trackpad moves around, these phototransistors tell the board, or the app tells the board the current state of the trackpad by means of the phototransistors. Also, if the light were to go on, and you'll see there's an additional light on there, and as I move the cursor around the trackpad, then one can see that the lights are changing, and this is how the direction is controlled via the web interface. So one thing to note, if you're when you solder in the phototransistors, you'll probably be tempted to connect the anode to high, as is typical for an LED. Don't do that because they run reverse biased. Be sure to connect the cathode to high, so the shorter leg goes to high in this case. So the next thing I'll be doing is soldering in the headlights here and here, and then I'll also be soldering these in. So at this point, the phototransistors have been soldered in, as have the LED headlights. They share a hole here. They each have their own current limiting resistor, and they're connected to the emitter of this low current transistor. So at this point, it's useful to do sort of a smoke test to see whether things are more or less correct. One thing is to do a quick test for shorts, and so what I do for this is to connect an LED and and see whether it shines brightly. Shining dimly is okay because these phototransistors are exposed to light, and so there'll be a little bit of current flow through these pull downs. What you don't want to see is something like this, where it's something like this, where it's shining quite brightly. A little bit of dim light, that's fine. The next step is to connect it to the power supply and then bridge from the V-in to the headlights. So that's number 4 here. This is two digital. This will connect to digital 2, 3, and 4. Whoops. I'll turn that on first. And 2, 3, 4. And there's the headlights on. So this is just a brief sanity check. Of course, the key is to make sure that you did a thorough cleaning, let it dry, and of course check for solder ridges. The next step will be to connect everything together and then to see whether it will move around the floor via the web interface. This shows the board with the Arduino in place. You'll need to burn the sketch on or upload the sketch to the Arduino prior to putting it in place. Although I actually sometimes program it in situ. That is, I connect a programmer here. Either which way you prefer. The board should just slide into the headers that were added in the center. The only one that's tricky is A6. That's that one there. That one there. So there's two rows of headers on the phototransistor side. Just make sure that everything lines up properly. The raw should be lined up with this. Raw should be lined up with the supply from the positive rail, and ground with the supply from ground. And A6 should be in this this second row where there were just 3 headers, and all these should slide in properly also. So at this point it's good to go. At this point I'm going to put it all together and give it a test run.
The robot's down on the floor there, and I'm about ready to test. This is a relatively minimal body. It's just some scrap plastic and some cardboard. And it's front-wheel drive. The other robot was rear-wheel drive. First off, I'll try the lights. And after the lights, I'll go ahead and move it around a bit. Usually I test forward, back, left, right, and then just work with it for a while. So at this point I'll be moving it forward. And just turning it. Now I'll have it go backwards. And it's going backwards. Now turn each way. And I'll stop it. That's about as minimal as a robot can get with a web interface and video streaming. On the one hand, there's some limitations in terms of using the phototransistors as a means for communicating. The key is to make sure that the alignment of the phototransistors is flush against the screen, and additionally that the ambient light is screened out. Other than that, it's a reasonably decent project. It takes perhaps a day or two. There's more information available in the EyesBot blog. A link to the relevant blog post is included in the video description. Thanks for watching. I hope you enjoyed the video and found it useful.